Hello friends, welcome back to this channel. So, in the previous video, we show data sources in Terraform. Now, in this session, we will talk about VPC. So, without any further ado, let's get start the session. So first, we need to know how to create a VPC. And I am going to explain to you first what the VPC is. And then, we are going to do a demo on how to set up a VPC using Terraform. So, on Amazon AWS, we have a default VPC. VPC stands for Virtual Private Network. It's created for you by AWS to launch an instance in. Up until now, we used this default VPC. Every time that we launch an instance, it was launched in this default VPC. The VPC isolates the instances on a network level. It's like your own private network in the cloud. Best practice is to always launch instances in a VPC. You can do that in a default VPC, or one you create yourself. One managed by Terraform is the best choice. There's also EC2 Classic, which is basically one big network, where AWS customers could launch their instances in. Nowadays, it is best practice to launch everything in a VPC. Some cloud providers like DigitalOcean, they don't have something like the VPC. It looks much more like EC2 Classic, where you have just one big network, and if you don't set your firewall right, then someone in the internal network might be able to access some of your services, even if they are not supposed to. VPC is much better, because it's your own network. It's completely isolated from their customer's network. For smaller to medium setups, one VPC, one per region, will be suitable for your needs. An instance launched in one VPC can never communicate with an instance in another VPC using their private IP addresses. So, if you have two instances launched in two different VPCs, then they will never be able to communicate. They could communicate still, but only using their public IP, which is not recommended. Because the public IP goes over the internet, and from the internet you can reach everything. So, if those two instances also have public IP addresses, you could still communicate with each other, but that's not really recommend. Another solution, if you have two VPCs that communicate with each other, you can also link two VPCs, it's called peering, or VPC peering. That's also a possibility, but by default, what you are going to do is you're going to create a VPC, put instances in there, and if they have to communicate with each other, you are going to put them in the same VPC. So now, here's an example of a VPC that covers multiple availability zones, which are data centers in one region, and has multiple subnets, private and public subnets. So, on AWS, you start by creating your own virtual private network to deploy your instances or databases in. So, what you see on the left here is what you will have to create first, and then we will launch those instances into one of those subnets. So, main public one, main private one, those are called the subnets. Every time you launch an instance you will say, I want to land that instance in that subnet. Now this VPC on the left uses the 10.0.0.0/16 addressing space, and allowing to use the IP addresses that start with 10.0, like this 10.0, and then you can choose your numbering. This is VPC covers the EU West 1 region, which is an Amazon AWS region in Ireland. In this region, we have three zones, EU West 1A, EU West 1B, and EU West 1C. You will see that every region has two or three zones that are then denoted with A, B, or C. Now, every available zone in the VPC has its own public and private subnet. Take a look at the left, you will see 6 subnets. You will see a public and a private subnet. So, those subnets have a /24, so, you can assign 255 IP addresses. You see the three zones, EU West 1A, B, and C. And then, you will see a public and a private in each one of them, and those subnets have their own IP range. So, instances that started in a subnet main public 3 will have IP address 10.0.3. something that will be launched in the EU West 1C availability zone. Amazon's calls one data center an availability zone. So, in EU West 1, we have 3 availability zones, 3 data center, and if you launch an instance in main public 3, it will always have an IP address in the 10.0.3 range. An instance launched in the main private 1 will have an IP address, 10.0.4.x, and it will reside in Amazon's EU West 1 availability zone. So, we split up one VPC into subnets, and those subnets are done in a particular availability zone, and a subnet can be public, and subnet can be private. All the public subnets are connected to an internet gateway. These instances will also have a public IP address, allowing them to be reachable from the internet. So, main public 1, 2, and 3 are connected to an internet gateway. That's why there are public instances launched in that subnet that will have the private IP address, but they will also have a public IP address, and then it can reach those instances from the internet. Just a single instance that we launched earlier will have also a public IP address. That's how I was able to reach them from the internet. Instances launched in private subnets don't get the public IP address, so they will not be reachable from the internet. With a side note, that you can still have a mechanism called a net gateway that will allow the private instances to communicate outside, but not from outside to inside. Instances from the main public can reach instances from main private, because they are all in the same VPC. This, of course, if you set the firewall to allow traffic from one to another. If you have a traffic rule that disables that, they cannot communicate. But if you have instances in different subnets, but still on the same VPC using their private IP address, they can communicate directly with each other. Typically, you use the public subnets for internet-facing services or applications. Databases, caching services, and beacons, all going into private subnet. If you use a load balancer, you will typically put the local balancer in a public subnet, and then the instance serving an application in the private subnets. So, the load balancer is what you connect to from the internet, and then the load balancer can internally connect to instances in a private subnets. So from my side, that's it for the theory part. Now let's see how to use VPC with Terraform. So, for this demo, I will use the files in the folder, Demo 5. And here, the files that are relevant for this demo are the nat.tf and the vpc.tf. First of all, let's see vpc.tf. To create a VPC, this is the main resource here, the AWS VPC, with name main. And, also in AWS we give it a tag name, main, so they can see it later on in the UI, that you have a VPC, called main. CIDR block equals 10.0.0.0/16, and then, in this VPC, we'll create subnets that are of /24. Instance tenancy, default, which means that every instance that you launch will have a default tenancy, so you can have multiple instances on one physical piece of hardware. Enable DNS support, and the DNS host names, which on your instance gives you an internal hostname and domain name. Classic link is false. If you want to link your VPC to EC2 Classic, then you can put it to true. Then we are going to create the subnets here. Remember from the slides, we are going to have 3 private and 3 public subnets. We start with the 3 public subnets. These 3 here are public subnets. Here, we refer to the VPC, so AWS VPC main, and then ID. CIDR block is 10.0.1.0/24. You also going to give every instance a public IP on launch. When you have an instance, the instances will get an IP from this range, and you also get a public IP to connect to the internet. The availability zone, in this case, is going to be EU West 1A. If you want to launch in another region, you might want to change this, and then we just have the same thing for the other 2 subdomains. You see that here we are using 10.0.2, and the availability zone B, and here we use 10.0.3, and availability zone C. Then we have the 3 private ones. And the main difference here is that we don't map a public IP on launch, so if you launch an instance in this subnet, you only get a private IP address. Then we need an internet gateway, because the public subnets need to be connected to an internet gateway. This resource creates an internet gateway in this VPC. And this route table is something that can be pushed to the instances. We push a route, saying that all traffic that is not internal, 0.0.0/0, means all IP addresses, except the ones that match the VPC range. So, that will go over the internet gateway. That will then be pushed to the instances, but only if we associate this route table, which is created to every single public subnet. You have 3 public subnets, so we are going to say every time, this public subnet that needs this route table. The other ones we can leave as default for now. So, that is it for the VPC and a public subnets. Something about a NAT gateway in the theory part. So by default, the private instances only have a private IP address, and they can never access the internet. If you still want that the instances can access the internet, but not the other way around, like that the internet cannot access the instances that you are going to launch in a private instance, then you can set up a NAT gateway. This can be useful, for instance, for updates. So let's say that we run a database on there, but it still needs to fetch updates. Then you can send all this traffic through this NAT gateway, and only allows the NAT gateway to access, for instance, the service where updates run on. Now, to do this, you need a static IP address, EIP, elastic IP address called an Amazon. And that IP address, you are going to use to create an AWS NAT gateway. And then you do exactly the same as for the Internet gateway, but for the NAT gateway you say, you want to push a route, 0.0.0/0, that redirects or sends the traffic to the NAT gateway. And then, you associate this route table with private instances. This is completely optional. If you want a purely private subnet that cannot contact the internet in any way, then you should need to doing this. You just keep it at the vpc.tf, and you don't use this nat.tf. It really depends on your requirements. So now, if you want to run this without a NAT, then you just remove the file. Otherwise, you have to do Terraform apply. But here, I am going to do only plan. Here as you can see, it will going to set up the VPC. Okay? In the next session, I'm going to show you how to run instances on VPC. So guys, that's it for this video. I hope you liked it. I will see you in the next lecture. If you have any question or any doubt, feel free to ask in the comment section below. I will answer you as soon as I can. Thank you for watching. Bye and have a nice day.